All right, so this is lesson 2.2, the square root of a function. And the idea is here that we're comparing graphs of f at x and square root of f at x. Now again, you can read through all of this stuff. But the basic idea is that when we do this, the square root is the square root of the y value, not the x value. So again, if you imagine something like this, 4x squared, not plus, sorry, comma 9y squared, or a squared, b squared, something like that. If this is on f at x, then the mapped point would be still 4x squared, comma 3y. So you take the square root of the y coordinate, not the square root of the x coordinate. All right, so now the idea is here, let's say we had the function f at x equals 4x minus 3, and what I'm trying to do is graph square root of f at x. Okay, so we're going to start by making a table of values here. So we're going to start with x. So I'm going to need to make some more spots down the line, but that's okay. All right, so 3 and 5. Okay, so what we're going to do is we're going to put these values into our equation. So this is going to be my f at x. So if we put in 0.75, that's 3/4. So 3/4 times 4 is going to be 0. If we put in 0.8, that's like 4/5. So that's going to be, I don't know, 4 times 8 is 32. So 3.2. 3.2 minus 3 is 0.2. Now, I'm going to add in an extra spot over here. Let's put in 0.5 as well. Okay? If we put 0.5 into this thing, we would get 0.5 times 4 is 2. 2 minus 3 is -1. Okay? So I'm just going to add that point into the table so it's all going to make sense. All right, so put in 1. 4 times 1 is 4, minus 3 is 1. Put in 2. 2 times 4 is... 4 times 2 is 8, minus 3 is 5. 4 times 3 is 12, minus 3 is 9. And 4 times 5 is 20. 20? Yeah. 4 times 5 minus 3. Why are they doing this one? It would work a lot better if it was, I don't know, whatever, to get 16, but that's okay. So what we're going to do now is we're going to do y equals root f at x. And again, it's the root of the y value. Okay? So the root of the y value. So root of 0, hey look, that's 0. Square root of 0.2. Again, this is kind of an odd one to use. But if we put in 0.2 and we square root it, it's going to be like, I don't even know. Here we go. 0.2, shoot, clear. Square root of 0.2, and if we put that in, we get 0.447. All right, so I'm going to put that value in here, 0.45. We'll round it to. Now, again, I'm not really sure I like that example. Let's try a different number. Let's try 0.5, okay? If we go, or actually 0.25. If we go square root of 0.25, oh, I lost my 0 point here. Oh, I'm clicking beneath it. That's my problem. Okay, so 0.25 square rooted, if I don't crash my calculator here, is 0.5. Now you can think about that as 0.25 is 1/4. Square root of 1/4 is square root of 1, which is 1. Square root of 4, which is 2. So it's 1/2. The idea here is that when you take the square root of a decimal, the value gets larger. Anyway, back to here. Square root of 1, 1. Square root of 5, I don't know. That's kind of a nuisance number to deal with. So square root of 5 is going to be just over 2, right? 2 point something, something, something. Just over 2 because square root of 2 would be 4. Now square root of 9, that's a nice one, 3. Square root of 17, again, moderately ugly, but just over 4, right? Does that make sense? Now, if I pull this up here on Desmos, I'm going to graph it on Desmos instead of the graphing calculator just so you can see it more clearly. So I'm just going to pause this for a minute while I get all logged in. All right, so now I'm back. You didn't notice the pause, but I was gone for just a minute while I got everything logged in. So there is f of x is 4x plus 3. Let's actually make this projector mode so it's a little bit bigger and easier to see. There's that nice big red line there. Now what I'm going to do is set up and go y equals square root of f of x. Now remember, what that's doing is it's doing the square root of the y value. So here's those points. We could see 0.75 comma 0, 1 comma 1. Again, there was that 0.8. If we zoom in here, we can't see that exact point really nicely, but we can see that the blue line, which is my square root, is above the line. So that makes sense with that. Zoom out here again a little bit. And then once we get to values bigger than that, for example, 4 here, the value is 2. Or 5, the value here is 2.23, etc. But you can see the value there is always lower. So that's the things that we wanted to see there in this example. So the domain of this thing, the domain of this function is x is greater than or equal to 0.75. Now, why does it start there? Well, let's go back to here. Remember this other point we brought in, 0.5 comma negative 1? Well, what's the square root of negative 1? It's undefined, so there's just no graph over there. So the domain and range of each function. Okay, so the domain of the blue function is everything. Linears are okay, they're all the way around. X is an element of the reals. And for the domain of my root f at x, it's x is greater than or equal to 0.75. And again, because that's the point where the graph starts being real, when it hits 0. All right, now, if we do the range is y is an element of the reals for this guy, but the range for my square root graph is again starting at 0. That's the point where it starts. All right, so that's where that is. The values for which the graph is above the graph, that is everywhere. So let's do the above. My square root graph is above wherever x is greater than 1. Now that's not a very important reason to see, but really that means also when y is greater than 1. It was the y value that we really cared about. All right, so that's the part where it's above. It's below from the x values from 0 to 1. Is that really? Actually, sorry, it was below from 0.75 to 1. Because those are the values where the y value is between 0 and 1. And those are the values that we really care about. Now, again, I'm not overly fond of this example. Let's put an m here and a b. That's an m. Let's try that again. And a b. And again, we'll add all the sliders. Now, even if we change our values, you'll notice that no matter where I put my graph, the blue line is always above the y values between 0 to 1. Again, regardless of what the x values are, but always above the y values from 0 to 1. And it's below for every value after that. And again, that's going to be true no matter where I put this thing. Does that make sense? So you can see that that's kind of where those lines will always pivot together. All right, so that's what we wanted to see there. All right, on to example 2. Now we're going to do the same thing, but we're going to do y equals x squared plus x minus 6. Now that's going to factor to x plus 3, x minus 2. That's the factoring on that. So that factors to this. And then again, we're going to compare y equals square root of x squared plus x minus 6. Now again, that's not a straight up transformation, because our transformations are all transformations of y equals root x, and this is a parabola instead of y equals root x. So it's a little bit different. But comparing these things, again, because we've done our polynomials unit, we know that this thing has an x-intercept at -3, another intercept at +2, and opens up because it has a positive lead coefficient. That's what that looks like. Now, when we do the square root, again, what we want to remember is that it is at the same point when y is 0. So those are our first invariant point. It goes over, through, and then under. And again, the point where it goes through is at y equals 1. We don't really know where the x value is, nor do we especially care. We just know that it goes through when y equals 1. Does that make sense? Hopefully. If not, come in and ask questions. So, that's what the two graphs would look like. Again, while we've got it here in Desmos, let's just pop this into here. So it's going to be x squared plus x minus 6. And again, that's what it looks like. You can see these two invariant points here. And if we zoom all the way in on one, we can see that the blue line is, in fact, above the red line. It's just hard to see because the two lines are so close together. All right, so that's what that looks like. Again, just like I drew here. Now, the x-intercepts are at -3 and +2. The y-intercept is at -6. The max value is infinity, or you could say there isn't a max. And the minimum value is at I think it's 6.25. Let's check it in Desmos while we've got it here. I'm assuming that everybody still remembers how to find the minimum value with their calculator. But yeah, -6.25. So that's a 6. Doesn't look like it much, but it is. Now, for the new graph, the root of that thing, the x-intercepts are still at -3 and 2. The x-intercepts are the same, but there is no y-intercept. It just no longer exists. Why? Because the square root of -6 is not a defined value, at least not in our real number set. So the maximum value is again infinity. It's just going to keep going up forever, slowly but surely. And the minimum value is now 0. And what other things do they want us to know about that? Nothing. Okay, so now we're on to example 3. Example 3 is one of these ones where it's a drawn out value. Now again, I'm not especially fond of this one because it's so steep here, it's really hard to see the requisite points. But the moral of the story is that we're always taking the square root of the y value. That's the really important thing to look for. And remember that our invariant points are at 0 and 1, and the graph is above, between 0 and 1, and below when it's greater than 1. And again, we're talking about y values there. So the way I like to do this is I'm going to throw down some dotted lines at 0 and at 1. Again, why? Well, because the square root of 0 is 0, and the square root of 1 is 1, so those values don't move. So I'm going to draw my invariant point, invariant point, invariant point, invariant point. And note, invariant points are heavily weighted or heavily represented on tests. There are lots of times questions where we ask you stuff about the invariant points. So, what I'm going to do is I'm going to start at my 0. I have to, again, go over, through, and under. Again, it's kind of like the old, shoe tying thing. You go over, under, and through, except this time you're going over, through, and then under. So I start here, go over, through, and then if there's other key points, like see how this one's sloping up right here, and that's sloping down, my graph is going to kind of match that. And if I think about it, this peak here is at 3, 6, 9. This is the point negative 3, 9. You can't see that all that clearly from where I'm at. But this point right here is going to be negative 3, 3. Why? Well, because the square root of 9 is 3. So now it's going to kind of come back down. Now, this bottom line here is at 3. The square root of 3 is about 1.8. So it's just a little bit more than 2. So it's going to kind of come and do that, and then it's going to sit right between the green line and the red line. Again, that's a little bit of a challenge to see, but you can kind of see what's going on there. Agreed? All right, now I'm going to show you guys a really slick trick as sort of a bonus in this video here. I'm going to show you how you can plot lines like this with your calculator. So I'm going to pause the video. Well, actually, I'll start by putting it in. What you're going to do is you're going to push the Stat button. So again, it's right here under your Delete, your Stat button. Then you push Edit, and you can put information in your lists. If you already have stuff in your lists, you can go to the top of the list and hit Clear. So I'm going to go over, I don't know why my calculator is going especially slow right now, but we'll let it do its thing. And now what I'm going to do is I'm just going to put the coordinates in as I see them on my sheet. So I like the coordinate at negative 8, 4. That's going to be kind of over here. If you look at your sheet, there's one at negative 8, 4. So I'm going to put negative 8 here in the L1 and 4 here in the L2. Then my next nice point is going to be down here at negative 5, negative 2. So I'm going to negative 5 and then go across negative 2. Now I also have negative 4, negative 2. And let's put our zeros in as well. So actually I'm going to go in here and I'm going to push this one I guess I'm going to push this one down. Ooh, watch this trick. See, I need to put in the 0 between -8 and -5. So I can go in here. I want to go on my L1 and hit enter. And I'm going to go in here and just insert the 0. Now that's going to push the other values down. Oh shoot, I didn't even mean 0. I meant -6 because the x coordinate is -6. And then I'm going to go over to here, hit enter, insert 0. So there's my -6, 0 as well. I'm going to try and include all of the zeros here, at least approximately. Now, my y value here is going to be at like 3.8, -3.8, 0. That's probably not exactly it, but it looks close enough. So there's my other x-intercept. If I really wanted to make it look good, I could even put the values in when x is 1. But what I'm going to do instead here is just go up to the top, -3, 9. And then I'm going to put at 2, 3. And then let's go like 8, 3. Just to show that it goes along all of those areas. Okay, now watch this. I'm going to go second y equals. And this takes me to my stat plot. All right? Now I'm going to hit enter on plot 1. I'm going to turn it on. And then I'm going to say I want you to connect the dots. Now this is key. You need to make sure that these are lined up right. X list is L1. Looks good. Y list is L2 because those are the points that I put in. And I'm going to have it do these little random square dots. And now if I just hit, I'm going to make sure my zoom is on right. So I'm just going to hit zoom standard from -10 to 10. And there's my graph. See? Now this is the good part. So I'm going to go here to stat. Not program. Stat. I'm going to go edit. And over 3 in here in L3, I'm going to hit enter. And I'm going to tell it to do the square root of L2. Now to do L2, I'm push second and 2. That goes to there. And now watch. It'll populate my whole grid. Oh, although it didn't like my negative values. Ah, goodness gracious. All right, so what I'm going to have to do is trick this a little bit. Oh, heck. Okay, so I'm just going to clear this. So it doesn't like these negative values, which makes sense. I was hoping it would just put an error in their place. But so I'm going to change these to 0 and 0 just for now. And I'll put them back to -2 and -2 in a minute. So I'm going up to here, go square root of L2. And again, that's my second 2 is to get my L2. Hit enter. So it populates my list. And now again, I'm going to go back in here to these two values at -5, -4, and turn them both back to -2 and -2. Again, it can't plot undefined, so I'm just going to plot it as zeros. Then, there's my original graph. Now again, what I'm going to do is now put a second plot in. Oh, sorry, I've got stuff in my Y1. Let's clear that out of there. I'm going to push second y equals to get to my second stat plot. Turn this one on, except now I'm going to plot L1, so second 1, and L3, second 3. And let's change it to the plus sign dot. And now if we hit graph, we will see the two graphs together. Now again, in reality, it'll be curvier than that, and it'll go through the ones. You'd actually see it go kind of over and under if you're doing this for reals. but that's what we can kind of see in our graph to see if we've drawn it correctly. Hopefully that makes sense. Hopefully that helps you out a little bit there. And other than that, this video is done. If you have questions, come find me in class.